WizardLM working and running and making queries. And if you don't know what a WizardLM is, it's this pretty awesome model. It's open source. It supposedly has pretty good results compared against OpenAI. And the main benefit is that you can make it run in, well, Google Colab and even on your MacBook M1 and M2 and other devices. You know, if you have a graphics card as well, it'll run. And the reason why you would want to do that is because you're not sending your proprietary data to OpenAI, right? And so that's perfect if you're in an enterprise and you don't want to send your data, right, to some third party vendor, right, that you don't have a working relationship with, except maybe Google, right? And it's also probably more cost effective. So it does have some gotchas that I'll explain at the end, but this is how it works, right? So here are your basic dependencies. You load your model, right? So WizardLM 7B. So I've gotten 7B working. I'll explain in a bit why I couldn't get 13B running. Then the next thing is that we're using Langchain. So we load our pipeline. And the important thing here, the two important settings that make this possible are these two parameters. So this will let it run in a hybrid mode. So it runs half in the CPU and half in the GPU. And that's what lets it run in this sort of, less powerful environment. These are just settings for the model to make it play a little bit better against coding tasks, right? Then once you load the model, you shove it into Langchain's Hugging Face pipeline. So we're going to be using Langchain. So Langchain has done all of the heavy lifting. So there's like no custom code here. It's just vanilla use of Langchain. Then we load our repo. So again, this is a Langchain loader that lets us clone this repo from GitLab. Then we load the files. Then we use this built-in chunking mechanism to parse those documents into smaller documents that the model can make better use of. The next key thing that we do is we make use of this vector store. Now, this vector store is important because otherwise you would be sending all of your data to the model, and your model can't handle that. So like you have a giant repo, like it can't parse your repo in one query, right? And so the way that the vector store works is that given a query, it'll find documents that are similar, right, to that query. And so ideally, those are going to be the documents that will help the model do the task that it's given. And there are several techniques that you can use to sort of get better results. But I won't cover these here for now. But the important thing is you set up your vector store against your repo. Then you set up the query, right? And and then in this particular example, it's how do I add a new CLI task, right? So the repo that I'm using is a personal repo where I have I've set up a monorepo, and one of the things that I've done there is I've set up these CLI tasks. And what I mean by that is, say, instead of every time I add like a new app to that monorepo, instead of like re-adding Ladle, for example, or Storybook, or enabling unit tests, right? Or what I did is I set up some CLI tasks to do that for you, right? So and so there's like a whole little framework inside of that monorepo to do that. And so I asked it, how do I do that? And so here's what WizardLM said, right? So how do you add a new CLI task, right? And so this is that result that I got back, just shoved in here. So I haven't even formatted. And here's what I got back. And it said to get a CLI task, you got to extend the command class, right? Because I'm using this thing called clip-onion, right? And this is pretty much the example here. This is pretty much a working example of how you would add a CLI task. The only thing that where it sort of screwed up is that it didn't talk about how you actually hook it up to that CLI package. But that's okay. I think this is probably, if I were like trying to refresh my mind how to add a task, this would, this would probably point me in the right direction. The next thing I asked it is, how do you use the hamburger menu component? So in my monorepo, I have like these components. So basically I have a tiny little component framework, right? And one of the things that I have is a hamburger menu component. And so I asked it, how do I use that? And so pretty much what it did is it took some documents that I had and it sort of summarized them and put them here. So this is mostly correct. Here it just, I don't know, it had a little bit of a parsing issue, but like this is pretty much very usable. And so back to where we were here. So we're using the smallest WizardLM model, and I'm actually having very excellent results. One of the things that I was not able to do is I was not able to get the bigger model working here. And because the reason for that is that there seems to be some bug here in this phi CPU, right? So here we're telling it we're going to only use the CPU, but for some reason it uses the GPU. And when you use a bigger model, you use up all the GPU memory and you try to load your vector store and it blows up. Another thing that I wasn't able to get working is the map reduce. Here's map reduce. Where's map reduce? So this is, I had alluded to earlier, like the different techniques for getting stuff out of the, working with your large repo with the model. So this is one of the techniques, and that I couldn't get working. These aren't deal breakers in my opinion because this space is moving so quickly. In a couple of weeks, if not days, I'm sure these issues will get resolved. The main issue though is, I think if I want to direct your attention here, is I asked it this question: how to use the hamburger menu context, and if you notice here, it took almost a minute to run. And so I think that's probably the biggest downside right now. So when you run stuff inside of Google Colab, it's not very fast. So queries take, up to a minute to run. And that to me is probably the biggest issue with this going so far. So next steps though. Some folks are actually working on an optimized version of getting models working locally in your MacBook M2 and M1s and M2s. And if I recall correctly, those are actually pretty fast, faster than this. So I think next steps for me is to try those, see how they work, if they're usable. And also, running in an Amazon EC2 instance, seeing how expensive that is, and if that compares to just using Open API. So that's it.